Okay, let's write this test that we've so carefully prepared for. So in our last video, we did the setup on a ViewController test, and then we created our MockBirdService. Now it's time to write our test, and we'll use the same 3 blocks for this test that we've used for the other tests, given the circumstances that we need to set up, when, the method that we'd like to test, then our expectations of the result. Inside of given, we need to set up one of our MockBird services that we created. So let's say let MockBirdService and instantiate our MockBird service. Good. Now, that MockBird service is going to need some birds to return. Let mockBirds, and here we'll create a collection of birds. Let's make a bird named Oriole with a description of angry and an image URL of birds.com/angry Oriole. Now you'll notice something about the data that I'm putting into this test. The test would work just as well if we had this Oriole be named A with a description of B and an image URL of C, but that kind of data would be completely useless to another developer trying to figure out the shape that our data might take from the API. So we use realistic values in our test data. I think it'll make sense for us to have at least 3 birds in our mockBird object. So we'll name those Cardinal, Angry Cardinal, and Robin. Angry Robin. Great. We know that when we call getBirds on our mockBird service, it calls the completion handler with the mockBirds and mockError attributes. So we need to set our mockBirds attribute here. MockBirdService.mockBirds is equal to the mockBirds that we instantiated right up here. Good. So now we want to start calling methods on our ViewController. self.systemUnderTest.viewDidLoad. Let's take a look at what happens right now inside of viewDidLoad. So we can go there by command clicking on BirdList ViewController and jumping to the definition. Currently in viewDidLoad, we set the bird service on our ViewController to a newly instantiated real bird service. Then we immediately call getBirds. There are a couple of ways to add functionality to a class in object-oriented programming. One of them is to have your object inherit from another object. For example, the reason that our BirdList ViewController has a viewDidLoad method is that it is overriding it from its superclass, UIViewController, which already has an implementation of those methods. Another way to get additional functionality into a class is to have it collaborate with another class, and in particular, to have another class, such as the bird service, assigned to a reference on the original class. That's called dependency injection, or sometimes inversion of control. So now, instead of the control belonging to a superclass, it belongs to another class entirely, which is assigned in as a reference, like so. Now, in typical object-oriented programming, the way that we tend to do dependency injection is with a constructor or an initializer. That is, if we were able to do that, it would look something like this. Let BirdListViewController equal BirdListViewController with a bird service attribute passed in the initializer. But we can't do this in our app because we don't have control over the initialization of our BirdList ViewController. Instead, the iOS framework handles the instantiation of this ViewController from the storyboard for us. So we need to be a little bit sneakier than that if we want to be injecting dependencies into our ViewController. Let's take one more look at the BirdList ViewController. Right now, When we call viewDidLoad, we immediately assign our BirdService to a new BirdService, and then start calling getBirds on the BirdService that we've created. The way that this code is written right now, we're not going to have an opportunity to inject our mockBirdService in place of the real BirdService before getBirds is called. So this is where we need to get sneaky. Do you remember the previous video where we talked about lifecycle methods on ViewControllers? We discussed how the lifecycle methods provide hooks for us to inject code into the running of the ViewController at various points during its setup and teardown. And we talked about how those methods run in a specified order depending on what's going on with ViewController instantiation. We saw that loadView is called first, then viewDidLoad, then viewWillAppear, viewDidAppear, so on and so forth. What we can do in this situation is take this code and separate it into another lifecycle method that runs after viewDidLoad. This gives us an opportunity to inject our mockBirdService at that method separation. So what we're going to do is override viewWillAppear. This runs after viewDidLoad, and once a ViewController is instantiated, viewDidLoad doesn't run again, but viewWillAppear always runs right before that ViewController comes on screen. So instead of getting the birds right when the ViewController's view is loaded, we are now going to get those birds each time the view is about to appear. So we cut the code where we call getBirds out of viewDidLoad, and we paste it into viewWillAppear. Now, because we're not assigning our BirdService right before we call it, we want to make sure that that BirdService is present before we go about calling it here. We can do that with a guard clause. Guard let confirmed service equal self.birdService else return. This hook method doesn't have any functionality straight from iOS. It just calls this method at a specific point in the view lifecycle in case we want to inject any code. So, if this method ends up doing nothing as a result of this guard clause failing, that should be okay. Now, instead of calling self.birdService on line 30, we call confirmed service. And in the separation between viewDidLoad and viewWillAppear, we can trade out the real BirdService for our mock. Like this. Self.system_test.viewDidLoad. At this point in program execution, the real BirdService is assigned to the ViewController. Self.system_test.BirdService equals our mockBirdService. Excellent. At this point in program execution, our ViewController now has the mockBirdService as its BirdService. Then, in the when block, it's time to call the method that will run that code. Self.system_test.viewWillAppear. We'll have it appear without animation in our tests. Now, we want to do our assertions to make sure that the flock object on the bird list ViewController that contains our collection of birds was assigned properly, and to ensure that the table view was properly populated with those birds. We'll use two assertions for this. So first, we'll assert that our mockBirds has the same number of birds as the system under test flock. This assertion will pass no matter how many birds we have in our mockBirds collection, because we always assign all of the birds that come back from the service to our collection object in the ViewController. Now, let's assert that mockBirds.count is also equal to self.system_test table view number of rows in section 0, the only section we have. This ensures that the number of mockBirds is equal to the number of cells in our table view right now. And this would not necessarily always pass. The vulnerability here happens in our mockBirds collection having more birds than would appear on screen at the same time in our view controller. We know that iOS recycles those cells so that it only ever has as many as will fit on the screen plus 1. So if we have more mockBirds than that, this assertion will fail. It's important for us to understand the vulnerabilities of our tests, where they might become flaky or fail without the code actually having a problem with it, so that if something ends up failing, we can go in and ensure that that is the right failure, ensures that the code is broken, or is a failure as a result of a vulnerability like this. Let's run our test and see how we do. It passes. Excellent. Now, there's one more assertion that I want to use to make this test a little bit more robust. Because the way that this test is written right now, if for some reason the table view was already allowed to have 3 cells on screen before the birds ever got loaded, it would pass even if those birds never caused the table view to reload. Now, the reason we've left this until last is because this is where we start getting a little bit fancier with the test order. All of the tests we've written so far have 3 blocks: given, when, then. Now, those blocks are going to become a little bit more complicated. Because what we're going to do is we're going to put in an assertion at this point that our system under test, table view, number of rows is equal to 0. We want to make sure that that table view is empty at first. Then, when viewWillAppear is called, we get the data down that returns our 3 mock birds, at which point our table view should be reloaded with the new birds that are added to our collection, bringing the count to 3 instead of 0. Let's see that that passes. It does. Good. Finally, let's ensure that the code that makes it pass would cause it to fail if it were removed. So let's take that out. Our viewWillAppear functionality has now been commented out. And now if we run our test, it fails. Good. Our test is testing the functionality that we intended. So now we can go back to our implementation, highlight the things that we commented out, and hit Command/ to uncomment them. Hitting Command/ uncomments and recomments a block of code for you.